Hello everyone, welcome to Course Seated. Today we'll be learning about arrays in C++. So basically arrays are used to represent a collection of elements of the same data type stored in contiguous memory locations. Basically an array, the memory you have is located next to each other. Now suppose you have this kind of memory. Suppose you have a memory over here, you have a memory over here, you have a memory over here, and each has some partitions. So in arrays, whole array will be distributed over here inside this memory of size 5. So arrays are basically contiguous memory location vectors, you can say, in one way. So for beginners, we can say we can learn about 1D arrays. What are 1D arrays? So basically they're nothing, they're just a list in which we can store data. A one-dimensional array is basically a row of lockers, or you can say each locker has an index starting from 0 to n-1. So here you can say that indexing starts from 0, and so this is what I mean by that. Indexing starts from 0 and ends at n-1. So how you can declare and initialize an array? So for declaration you just have to write int array and then this bracket. Inside this, if you want to declare a size, you can declare the size by using this. Well, basically this is wrong, this is right, and this is correct. Also this is also correct. So you can't just declare array and just leave it as it is, or maybe you can, but I've never tried doing this. Let's check whether this we can do or not. So let's go to the code editor and check whether we can declare an array like that or not. Yeah, so you can't do it like this. Here it says the storage size of array is unknown, so this is the error you get. Now suppose you do it like this will run because we have now declared the size of array, and we can initialize the array like this. Okay, so we can't, but why? Assigning to an array from an initializer list. Okay, so basically we can't directly assign it over here, but we should be able to assign it like this because okay, so we can't just directly assign to whole array, but we can do it. But we can initialize it like this. Now suppose you want to print this, basically initializes the array to 0. Let's see what I mean by that. Other than so we can just print the values like this. So these are 1 0 minus 96 minus 1 and this. Why this happened? Because everything other than 1 is a garbage value inside an array. Now let's suppose I declare this as a global variable. That should also give us some garbage value. So for that If we don't want to declare a size, we can just declare it like this, and or we can do it like this. So next we have we can access it by just, how I already told you about a string. Its indexing starts from 0 to n minus 1. So now suppose you have a 2D array. For array you can also access the value by doing something like this. So basically this tells that the pointer is over here and you have to take the value from here. So that's why you can do it like this, but there's no need, because in arrays if you can do it one way, why should you even learn the other way? Anyways, let's move to 2D arrays. So you can think of 2D arrays as a table which has rows and columns, and you know there are even upgraded versions of arrays such as ND array. In this you can think of as a cube or hypercube. But there is no need to remember that. We always use only up till 2D arrays, at least for competitive programming. So 2D arrays are basically matrices or matrix, you can say. So what we can write is int matrix 2 comma 3. So this is basically just like in math. The first one tells us about the rows. The second tells us about the columns. By this what I mean is we can just write 2 rows and 3 columns. So A column, B column, C column, one row, 2 row. So A, B, C is the column and 1, 2 is the row, are the rows. So what we can do over here, we can just say that there is a board value. Suppose this is 2 comma 2, which equals 1 comma 2 comma 3 comma 4, and then we can say we can access the matrix by doing integer value equals board. So basically we can define matrix 2D arrays like this and this, and you already know one more method just using empty brackets. But yeah, so for board you can just choose the index and then it will just give you the output. So for multi-dimensional array you can just keep increasing the number of boxes, but we only require 2D arrays. So now there are some operations which you can perform on arrays. You can say there is a searching operation, sorting algorithm, reversing algorithm, insertion and deletion. We can do that in arrays by using some cheats, you can say. Basically, if we want insertion and deletion to be in an array, we have to just decide that its size keeps increasing whenever we want to insert something inside the array, and we make a new array of that size. But we can easily do that with vectors, so I won't be teaching that how we can do that in array, or maybe I'll just show you a glimpse of that. So for next, you can say that you should know prefix arrays and sum arrays, because these help you gain the time complexity order of 1 instead of order of n most of the times. And there are some different arrays too. Anyways, let's move to next. Basically, two-dimensional arrays, for grid travel you can use dx and dy, which contains the values -1 or you can just directly do def equals -1 comma 0 and so on, but I'll be teaching that later in graphs. So basically what you can do here, you can sort the array by using the sort algorithm, pre-built sort algorithm. I'll be teaching you different sort algorithms later in the video, but for now just remember that you can use sort array comma array plus n is the size of array. Okay, so we haven't defined the size yet, we can just define it over here, or we can just do it like this. Yeah, so this, okay, so I used the wrong bracket over here. Yeah, so this should be correct. So let's see if we can compile this without any error. And yeah, we got 0 1 2 3 8, the sorted array using the sort algorithm. We can also use lower bounds. What basically its time complexity is order of n log n, and for lower bound we have, requires the sorted array sometimes. Sorry, always it requires sorted array always, but we have to use this sometimes because we can already do this using binary. So I will be teaching it over here. And there is one more thing, that you can use unique algorithm inside array, but that we can also do, using for loops. So I won't be teaching that either. So for now, just remember that you can write it like this, and you can declare 2D arrays and so on. But what's most interesting is there's a pointer way to do this. And what's the pointer way? So if a pointer points to array of 0, which array does? So by saying that, what I mean is, either you can do it like integer integer x equals a star array, and then we can do so what we are doing, we are going from 0 to n minus 1, and then we are printing out the array. And what we can do is, either we can do it like this, or just let me show you another way. So we can do it like these four, like these four stuff. Let me just show it to you what I mean by that. Okay, so this was, okay, I didn't end the line. It's in the line. So we are getting 3 2 3 3. Why are we getting 3? Okay, so basically I'll tell you why are we getting this 1 2 3 4 5. Basically I didn't have to do it like this. Okay, so we can do it either like this, but that will also give us the same stuff. So let me just use a star over here. Oh, okay. So invalid type argument of unary star have n teacher. Oh, okay. You can use auto over there. Mm. Oh, okay. So we have 0 over here. So we can just do it like this. Basically, yeah. So we didn't have to use a pointer over there. But yeah. So this will just give us the address of, the address of whatever we call it. So it should give us address for what we want. So basically 048 and then 7C80. Why was this 80 by the way? I'll check later why was this 80. Anyways, so what I was saying is you get cout array I as one and then its address over here, and then afterwards you can just print from the address array plus I. This will give us you what do you say, this will give you the answer, basically what's at ith index of array. And this also gives the same. Why we can do I array? Because this basically means array plus I. This means the same as star I array plus I, or I plus array is equals R equal. So this prints the same value as that. So basically we have 111, 333, 222, and so on. Now suppose you want to check why this is happening. Why is this getting FC instead of F12? So basically this happens because you can say that it doesn't go 2 digit over here. That's how your compiler works. It can't show you 2 digits over here, so it just changes to hexadecimal. Basically these all are hexadecimal only. So the address is stored in a hexadecimal type. Well, you can say the address is stored as hexadecimal. So instead of going to 12, it just changes the value as C, and for this we get A00. So basically these three define for our these changes. So per hexadecimal you have 0, 4, 8. So you have three options per the last digit, and then other digits start changing. If you're not getting that, you need to learn how the backend of compiler works. But for that, I'll be using the different course, or I'll be introducing that in a different course. I won't be explaining that over here. So what I was saying is you can either use arrays, but in competitive programming we mostly use vectors. So I'm pretty sure that you all have heard about vectors, and it's much more useful than arrays, because these arrays are fixed size, and you can't even declare them however you want. So I would say that these are not competent with competitive programming. But there's a way that you can change the size of these stuff. Let me just show that to you quickly. So suppose you are given a main array, major array. So basically I'm doing +5 because we most of the time declare it more than whatever we need. Okay, so I forgot that I haven't taught you all about functions. So maybe I'll be just, what did I write? Array. We can write a, yeah. So where was I? So I was, yeah. So basically I was at, we can just push it like this. Let me just define an array, then we can just declare however we want to do that. Let me just quickly show that to you. Basically, we've already declared it to 1 is x plus 5. That's the max size, and then we can just keep declaring if we want. And we can pop the same stuff by doing, if sz is greater than 0, then we can just keep popping from the back. We can just decrease the size, and that value will just get deleted from there. Well, what I mean is, this is what I mean. So we are not deleting the value, we are just decreasing the boundary of that. Anyways, this is, this you can say is good to know, because in stack and other stuff we'll be doing this push and pop. So it's good to know this method too. Anyways, this is what, how much I wanted to teach you today. Next we'll be going to the vector, the best part of competitive programming, or DSA you can say. And vector is mostly used in everywhere you can say. Like in networking we use a stack and queries, but over here we use vectors mostly. And even in backend programming we'll be using vectors only, because they are more sufficient than arrays. As I've already told you that the size can be changed and array can't change its size. So thank you everyone for watching. Let's hope you liked it.